Hello.
Okay, we're live. We'll check the sound. Hello, we're back.
Hi,
Um,
we're Philosophisciencing. My name is Ruby, and
I'm Nathan.
we're gonna talk about several things today. But
Space
space
stuff.
news,
Yeah.
yeah, I think
Space
that's.
up space apocalypses like
I
that.
know. When we were like, "What are we talking about this week?" I was like, "Oh, my partner and I are gonna go look at the meteor shower this weekend. It's gonna be so nice." And then we might catch an aurora because it's currently a solar storm. And I was like, "Wait, let's like look up, how these things can affect humans on Earth." And then it was just like it got darker and darker
And it
and
was it was
more and more
scary.
scary. Yeah. I'm genuinely scared. I did not have this like worry, and now I do.
Uh-huh.
Because, like, in my mind, I was like, auroras are just like pretty things that happened occasionally, like in the North and South Pole. And, it's like a magnetic field. Like, cool. I didn't realize that it could like potentially, in like, if if it happens, we could potentially lose all of our electronics and be like shot back 200 years in human history and be like using steam engines like we would back in steam engine
Uh-huh.
era. All of our like internet down, everything not working, and I was just like sat there and I was just like, oh wait, we are currently in this right now. So uh
Hmm.
okay, wait, so I did some homework because I didn't just want to like fearmonger without the facts. But now I can
That's
fearmonger with the facts.
good.
So currently
Oh,
we
okay.
are in solar cycle 25. And so
Hmm.
the solar cycle, basically every 11-ish years, our sun, our mother star, decides to flip its magnetic field, like just flip it. And during that time when it flips, you get a solar maximus, and then in every 11 years it goes from solar maximus to solar minimus. And currently we are in solar maximus of
Uh-huh.
solar year 25. And that also means that there is an increased amount of a bunch of things happening. Wait, hold on. Let me go to my notes. So during this time, there's increased sunspots, increased solar flares, and these things called coronal mass ejections. And so these coronal mass ejections, on average, normally comes out like two per week. Even now, like I mean, even on like not Maximus times, but like during Maximus, you can get major CMEs. And during these times, these major CMEs can really like they can be so big that they can hit. They're like seven times the width. It could be seven times the width of Earth. So basically, it'll hit the entire Earth. And when it does that, it can basically inject it, like flips our electric pole for a little bit. You can get auroras that are like around the world, and then we get a bunch of like DC power that we did not intend to have in our wires, like all of our wires, and then it just like fry everything. um and
And so
specific
so you said this is CME, so the Earth is being hit by something that's like being shot out of the sun.
Yeah, so the CMEs are eruptions of plasma and magnetic
Hmm.
field. Specifically, this huge injection of magnetic field, and especially if they happen back to back. So, like, let's say you have a CME, and then like immediately after you have another CME, like a couple. Like the first CME will
Uh-huh.
like clear the way, and then the second CME will just like augments it and makes it even stronger. And if
And
you
so
hit
it's clearing the way, and that kind of it's sort of like distorting the Earth's magnetic field. They're kind of like
correct.
altering. Yeah.
Yeah, so we already know. So when that happens, like the one way we can see them is in these auroras on our poles. So basically, it hits the Earth's magnetic poles and it like inverts it and sends it around the other side. Um, when these major ones happen, the whole Earth can be like in an aurora. Like, I wrote down like a description of what people said. So there was the first recorded event was called the Carrington event, and it happened in 1859. And it was the largest geomagnetic storm recorded, according to by humans. Well, at the time, and also even now, it's one of the biggest ones. And it
Hmm.
was caused by the CME, and it traveled directly toward Earth. It took 17.6 hours, and when it did it, like the solar winds, the like there was no solar, less solar winds because like on the 29th of August they had like a bunch of CMEs, and then on the 1st of September, 1st and 2nd of September they had more CMEs. So it was basically like 3 days in a row where there was CMEs, and so they just like came and hit us, and in like 17 to 18 hours there was an aurora that was seen around the world, like completely the entire northern southern hemisphere,
Right.
like in the Rocky Mountains,
And
like.
so normally you would see auroras like just like near the poles, right?
Correct. Usually it's only in like north, like the Australis and the Borealis, like in the north and the south. Like this was like everywhere, and it was so bright that like people that were mining for gold were like, oh, let's like start making breakfast because they thought it was morning. The birds started to sing. The
Huh.
birds were like, it's morning, and then
I
there's
feel
like.
like an aurora doesn't really look like morning. Like I'm kind of surprised by this. Like I thought you were gonna just be like what they were like, what the hell is that? Like
Yeah,
that they
so
were
it
just like, oh,
it
I
doesn't
guess the
start
sun is
gold.
extra weird looking today.
Yeah, well, it doesn't start green. So like the green is the lingering
Okay.
end effect. It starts like
Uh-huh.
gold red. Like it starts like a sunset, sunrise. So imagine like the
Hmm.
whole world just like sunrised in like the middle of the night. And then it became green afterwards.
Hmm.
That's pretty wild.
And so
So
it becomes green kind of as the energy level like drops off,
yeah.
or
Yeah, as it like
yeah.
gets absorbed or like dissipates or gets like just lingers. Um yeah, people could read the newspaper with the aurora's light. Um, like people could see it in central Mexico, in Cuba, and Hawaii, Japan, and all throughout China, New Zealand. Like these are all accounts of it. And in this time in 1859, right? 1859, like the only huge electrical system we had was like telegraphs. So
Hmm.
so telegraph wire. So there's like wires that are north to south are more affected than wires that are going um horizontal. That's not right, east to west. But they
East
were
to west,
all
yeah.
they were all affected, and so basically a bunch of telegraphers, like the people that like hit Morse code on the buttons, got electric shocked, and then
Hmm.
they were told to unconnect it to the power system, and the telegraphs worked. Like they continued to work without power. They were just literally powered by DC aurora energy from the sun. Like they could
Hmm.
continue sending their telegraphs to another telegraph person that was, while the wire was not connected to power. For
Huh.
that's
Yeah.
how.
Okay, I remember reading one story about this where they were talking about how just like there was so much kind of current that was being generated by this like solar event that um like basically like the telegraph things just had sparks kind of coming off of them.
Yeah, like I mean, if they hadn't unconnected the batteries, and like I mean, people were shocked, right? Like, and
Hmm.
that was like
Yeah,
1859. Imagine the kinds of electrical power we have now, like the power grid we have now, and like the amounts of wiring that could just get fried. And then I went into
right.
the, oh my gosh, are we prepared for this? So we are prepared, kind of, sort of, for the small, like twice a month, twice a week sun
Solar
CMEs.
storms.
Yeah, so
Uh-huh.
though like we have these capacitors, and then we have that basically filter out DC current, because like everything on our power grid, at least in the US and most of the world, actually is alternating current. So they let
Hmm.
AC go through but not DC. And so by doing that, you can kind of like filter out some of it, and then it'll like protect that wire. But any of the places that are not protected, now that all the extra DC energy is going to go there, and so then it will like burn those parts out. And like it's actually not unprecedented that this is a problem. So like power companies are constantly working on like improving this. And even in our lifetimes, let's see, what year was this? In like northern Canada, like New England, northern Canada, and I think it was like 1998 or something. Hold on, there was a huge one. Hold on, Canada, DA. Canada. Oh yeah, so 1989, Northeast Canada, it had rolling blackouts, um, all through the Northeast. So basically, because like it hit a couple of these wires, it overpowered it, and then it caused them to like they burned out the capacitors, and then like this part of the grid went down, and then like when one part of the grid gets too much energy, or like when it gets blown out, the other parts of the grid gets overpowered because like the energy has to go somewhere, and then it just causes that one to burn out, and then when that one burns out, now the what's left has like twice as much to like carry.
Right. So you get
um
this like cascading failure.
yeah, cascading
Um,
domino effect failure. And so when we have like
yeah.
massive power grids that like, for example, powers like all of Europe all in one giant big power grid, you can end up with a domino effect where all of it just goes
Yeah.
down.
So there was a thing that happened in Spain recently, and I was kind of expecting I was them to say it was because of a solar storm, because like we are at this like solar maximum point where basically, but actually it turned out to be not a solar storm. It actually out to just be like a really big fluctuation in demand on the grid. But essentially, all of Spain and Portugal just completely lost their power. And I think the interesting thing about this is that it turns out that a lot of electrical power plants need the power grid to start up. So they were without power for like 12 hours because doing this kind of dark start of these power plants when there isn't a functioning power grid was actually turns out to be really difficult.
Just
And
starting is hard.
mhm.
Wow.
Yeah. And interestingly, the other part of this is so like, I mean, so there's like a couple of different kinds of ways that the power grid can fail. And like we think of it as like, okay, there's stuff being overloaded or stuff being like breaking down and it no longer like conducts electricity. But interestingly, the other thing that can happen is that essentially um stuff can shut down when its safety systems are triggered. And in particular, what they think happened here is that as we've gone to having more renewable sources of power, the grid has kind of less what they call like inertia or reactance, which essentially means that kind of like if the power consumption changes a lot, um, it's harder for the system to react to that and buffer it. And it kind of comes from this idea that kind of when most of our power was supplied by generators running turbines from fossil fuels, the generators have a lot of physical inertia. So, for example, like if the load on the grid increases a whole lot, it actually slows down the generators a tiny bit, but they have enough inertia that that doesn't happen very much. But when you have systems that are running on batteries and solar panels and other things, they seem to both be more vulnerable to this, and also they can switch on and off more rapidly, so they create problems like this more. And so the interesting thing that happened in Spain is that it seemed like it was basically some sort of fluctuation triggered a bunch of the safety systems that caused some systems to immediately disconnect from the grid. And this just caused this kind of basically just it wasn't like anything was broken, it was just that kind of the parameters went out of bounds, and that caused this cascading signal that caused everything to disconnect because all the safety systems are just like there's something weird going on.
Yeah, let's go to safety mode. Oh, I was just saying that I
Right.
was just thinking that actually that safety mode is one of the ways we can protect ourselves from these CMEs,
Yeah.
is to basically
Mhm.
just drop like inject the energy into the earth. like it,
Right.
like
Yeah.
just like it's like we have extra power, like it's just so they will do that, right? So they'll have forecasts.
Mhm.
They're like, okay, in 18 hours something's going to hit, these regions, and so in those regions they'll take the power grid and like literally just dump the power, and that way if it gets over energized it would just come back to normal amounts of energy. So like I guess that is one of the ways you could protect it, and it also has a double-edged sword, as in once you
Yeah.
stop it completely it's hard to start over again if you don't
Right. Yeah. It's
have
like
these
it's not
generators going.
it's like I think it's interesting that like that in itself like caused so many problems. But yeah, I mean I think there are I mean I think one of the good things about it too is like so what's happening in these geomagnetic storms is essentially this plasma ejected from the sun kind of dents the Earth's magnetic field, which means that from the perspective of anything on the Earth, essentially the magnetic field is no longer static. It's now kind of moving around you. Um, And when you put an electrical wire in a moving magnetic field, then you get an electric current. But the good thing is that like that's kind of proportional to the length of the wire, right? So the more
Yep.
wire you have, the more current it picks up in the field. So if you can basically just shut down certain interconnections, you can make the effective length of these power transmission lines a lot shorter, and then they're less damaged.
Yeah, for small CMEs. For
Yeah,
small
yeah.
CMEs, like that works. But like
Mhm.
even in the 1970s, so in the 1972, a bunch of mines just like blew up, like with because of the sun. Like I was just sitting here and I was like, I'm such a glitch monster in the lab. Like things just like stop working for me sometimes. And then now I'm just like, wait, can I just blame it
You're just
on
like,
like a
it's because
solar
of
flare?
solar
It's
flares.
neutrinos and solar flares. And it caused random amounts of electricity just like doing their thing.
This makes more sense than my ghost theory. Did I tell you my ghost theory?
Wait, I want to hear your ghost theory.
So my ghost theory is that if I came back at like so ghosts traditionally like haunt the living to warn them of stuff, right?
Yeah.
So if I came back as a ghost, that would mean all my ideas about like the role of the brain were wrong. So therefore, I would haunt neuroscience labs to warn them that their theories were wrong. And this process explains all the weird results. It's that the labs are being haunted by the ghosts that are trying to pass on a warning to us.
To be like, don't study that. It's wasting
Yeah,
time.
yeah,
Study
yeah.
that
It's just
instead.
like I'm here to warn you that your theories about the neural correlates of consciousness are wrong.
Oh, yeah. I mean, I'm
Anyway, it
still
could be that too.
yeah, I'm just still stuck on the fact that like all of our internet, GPS, all our satellites, all telecom system, aviations, like Wi-Fi, like all of it could just disappear in like
Mhm.
with like a notice
Yeah,
of like 18 hours.
yeah.
Like we would just
I
go.
will say, like, and I think that was when I was reading about the Carrington event. I think that was one of the things that really stuck out to me is like one of the things that like, a lot of people emphasized was that this happened at a time where there was really very little electric infrastructure at all. Like, it would have been much worse if it happened in the
Yeah.
modern age.
Well, and even in 2012, we missed a
Mhm.
Carrington level event by like 9 days. Like the
Wow.
Earth had moved, and like the
Out of the
the
path
major
of
pulse,
it.
it
Yeah.
moved out of the path, but like only 9 days. Like the window of us, like
Mhm.
like there's a probabilistic, and then there's also like we don't know when the sunspots are gonna eject, and like until it starts traveling towards us, and you're like, oh shit, it's coming, and by then you have 18 hours. Maybe if you're lucky, you get 18 hours.
Yeah.
And
It is pretty, I mean, I do think it is pretty cool some of the things we've built to like predict this. So we actually have satellites, including some that are actually orbiting basically between the Earth and the Sun, where there's specifically like for space weather prediction. And that's, I mean, that's what gives us that early warning is that they're looking at the sun and they can detect these CMEs. And that does give us like some time, especially like so it's also a problem for it's all for people in space and people in airplanes
yes. Oh
and
my
actually a
gosh.
lot of satellites too.
That's so scary. Imagine if you got hit and you were in a plane. When it happens.
Yeah, I mean it does happen, and I think so the interesting thing is apparently the main risk to the planes is not the geomagnetic part, but just that you're getting hit by all the protons that are emitted by the sun because you're above a good. So normally the magnetic field is deflecting the protons, and that's what's actually causing this aurora. But when you're in a plane, you're kind of above a good chunk of the magnetic field, so you just get irradiated quite a bit. Um, a lot of a lot of airplanes actually, if there's or a lot of airlines, if there's a severe solar storm predicted, they will actually change their routes. So
Oh, to
they'll
go around it, or
right,
delay flights.
they won't take like high latitude routes. So they'll like if you're flying to like Iceland or Norway or something, the flight
Yeah.
will either get canceled or it'll take a slightly less efficient route that because kind of the closer to the equator you are, the less solar radiation you're exposed to.
Yeah.
Um,
Yeah. Like, oh yeah, so if you're in the news, you hear something called like the disturbance storm time index. Like that's what it's measuring. These are the solar
mhm,
storms. Um
yeah,
uh yeah, and it like, it weakens the Earth's magnetic field like
yeah,
which protects us from um
yeah.
yeah.
Also, another another fun thing that I wanted to, I found this on Twitter actually, and I was looking up a thing to, let me just pull that. Um, oh yeah, here it is. So it turns out that US invasion, and like this could be a completely spurious correlation, but it turns out like US military interventions in the Middle East correlate really well with the solar cycle.
Huh.
Um, and yeah, so like so this is showing the number of sunspots, and this is when different historical events happened. Um,
Is it also approximately every 11 years?
Yeah, so I feel like that's kind of like what might be happening is that like just like these things like they're just like has to like maybe there's just an approximately 11-year cycle of like us forgetting that like invading the Middle East is bad, and there's also an approximately like 11-year cycle of sunspots. But apparently, like, so that is one hypothesis. There is also a hypothesis that like these solar storms can influence human behavior too. And so this is like a lot less proven, but it is an interesting hypothesis, and people have looked at kind of like societal trends in this. And the theory there is like, okay, well, I mean, our brains are also sensitive to these electric are also sensitive to electric perturbations. This is actually the same principle by which TMS works to stimulate the brain. So in theory, it could be that the solar cycle also influences human behavior in some ways.
I lean on remember the website that has correlations of like things that
Yeah,
are
yeah,
super
yeah.
correlated, and you're like, I don't know about that. It
Like
correlations,
maybe
not
that
causation. Yeah.
like maybe we decide like it's just that like every like 11 years we like forget that it went badly last time and
Yep.
then
Every 10 years we're like, nah, we could do it better this time. And then we're like, oh fuck, we shouldn't have done that. And then we forget. And then 10 years we do it again. Unfortunately. Um oh
yeah.
yeah, I thought this was gonna be such a light one. I was like, oh, the Perseid meteor shower comes in every August. You should go camping and go look
I
at
mean
some shooting stars.
that is a more fun one actually. So like this is not a solar storm, but it is sort of a storm, which is that we're very I think like from like the 12th to like September 7th, right, is
Yep.
the peak of the Perseid meteor shower.
Yep, I think that's right.
Um,
That's this coming week between
mhm.
there should be like shooting stars or meteors between 10 to 20 per hour. So
Wow.
basically just stay up and just stare at the sky and it'll look nice. I mean go somewhere dark and you should see a lot of them. We're going through like the meat of the comet, which is pretty cool actually. And it's cool
Yeah.
that it comes back at the same time every year, and it's like summer,
Mhm.
it's like summerish time, it's like peak camping time. Unfortunately there's a moon this year that's pretty full, but you should still see it. Like you'll see them. It'll be really
Yeah.
nice. It'll be super cute. And if you don't see it this year, you can see it next year.
Mhm.
If
Yeah.
we don't hit, I mean, I guess even if we do get hit by massive solar storms that are Kerrigan level events, there will still be shooting stars next year this time.
Yeah, I mean, then it'll be darker, so it'll be easier to see the meteors.
There wouldn't be as much light
Um,
pollution.
yeah.
In fact, there will be no light
Oh man.
pollution.
I'm sorry. This like is so existentially terrifying. Like we're like, oh, fun space facts, and then
Yeah, I didn't
they
like
were
I
not.
knew I kind of sort of knew about the Kerrigan effect. Like I didn't
Mhm.
realize that we were so vulnerable to it to this day. Like,
Yeah.
and there really isn't anything we can do about it. So I guess we just pretend it's not like if it's so bad, there's nothing we can do about it. We just
Right.
pretend it's not gonna happen.
I actually knew about it because I went through a phase like a long time ago where I was just reading about like all the random like space stuff that could potentially kill us and like that like we couldn't really do anything about. And like there's a lot of things. It's just like stars periodically emit these like high energy bursts of gamma rays. And so it's possible that like at any given moment, like half of the Earth could just get irradiated by some random star and like everyone would die.
Yeah. Oh, like I didn't realize that we had such a near miss in 2012. Like I was just mindlessly going through college in 2012. Do you know what I mean? Like I didn't know
Yeah,
how bad it was.
like
Like
that
how
we almost got,
yeah,
yeah. It
it
would have
was
been weird if like that was like the thing that was supposed to cause the Earth to cause the world to end in 2012. And it's like, oh, we missed it. Okay.
oh, is this the Y2K thing? It was actually
No, it was
supposed to
like
happen.
there was a lot of like so there was a lot of people making predictions based on various like interpretations, like usually incorrect interpretations of historical texts that the world was going to end in 2012. Um, um,
Skin of our teeth. And I think it
yeah,
was around this time of the year too. I think it was like in late July. Yep. It missed
I
us.
do have a I do have a happier space fact that's related to that, which is like so early 2000s there's a ton of movies and stuff about like everyone dying because the Earth got hit by asteroids or something.
Yeah.
Like there was like Deep Impact and Armageddon and like a whole bunch where it was basically always like they had to like go and blow up the asteroid or whatever. But like it turns out we actually have gotten maybe because of that extremely good at like tracking all the objects that could potentially run into the Earth. So now we are actually very confident that there are no large objects in orbit that could cause a disaster on Earth. Like basically, we've actually been able to map out all of them, and we're very confident that there isn't anything that's going to hit us in the next like 100 years.
Oh, that's
Um,
nice. Like you mean
yeah,
space trash? Like we kept track of our
like
trash.
I mean, like I feel like space trash is like that's usually like the human made stuff versus what they're looking for is like asteroids that are just in orbit around the sun that could impact the Earth. And I think
Got it.
those are more worrying because those are moving so fast with relation to the Earth that like you could count kind of a dinosaur extinction type event.
Yeah.
Um, but I
So
think
we're good
over
for 100 years, is what you're saying, according to
pretty much,
those
yeah, yeah.
calculations.
Over the last 15 years or so, we've basically ruled out any chance of this happening in the foreseeable future. Which
That's
is
great.
is nice. Yeah.
That is nice to know.
And the other nice thing about that is that so if there's an asteroid that's going to hit us in like 200 years, like that is actually enough time that we could launch a probe to it and redirect it.
Like tilt it by that much and make it go.
Exactly, yeah.
Yeah.
And NASA has actually tested this. So we sent a probe to it was called the DART mission for Dual Asteroid Redirect Test, and we found an asteroid that was not going to hit us, but we were like basically was in a good position for us to test out this technology on. And essentially, you take a very heavy space probe and you basically just park it at a continuous. You just kind of park it near the asteroid at a continuous position. And it turns out that the probe, if you do this for a long time, the probe has enough gravity that you can actually slightly shift the asteroid's trajectory.
Oh, okay. I totally thought you were gonna say it like controlled crash into it, and then like made it go. We had
Right.
like a we had like a billiards ball situation, but
So
it.
we've also done that with some comets mostly because we wanted to see like what was inside the comet, so we just blew it up.
Yeah.
But I think so. I think the reason they don't tend to go for like let's blow up the asteroid is that like the concern is like if you did that, you might just end up with a cloud of smaller asteroids that are still on the same trajectory, which is like not really better. Like it's better if you can actually like change its trajectory. And like the tricky thing about hitting it is that you don't know what the asteroid is made up of. So if the asteroid is very solid, maybe you actually do change its trajectory by hitting it. But if it's something that's like a fluffy ball of gravel, then you just end up getting hit by like slightly more dispersed gravel, which isn't
Yeah.
actually helpful.
I was gonna say you could also change something that was not originally gonna hit us and make it.
Yeah, yeah, yeah.
I was like, that sounds worse.
Mhm.
And like I'm kind of sort of worried about these decisions because these are like world decisions, right? Because like if you like
Yeah,
one space program on this planet makes this decision, like like when it crashes onto Earth, like it could crash onto any part of Earth, right? Like so,
yeah.
um, so then like when they have like how like we're really shitty at like controlling what happens in the ocean, like trawling just
Mhm.
happens because it's like, oh, we're in open water, and then like devastation, and like they're doing the equivalent of like mowing down Amazon forest worth of ocean floor every day, and no one says anything because it's the middle of the
Right.
ocean and it's international
Because it's
waters.
like in an international space. Yeah.
Yeah, and the people that hurt from it are all the people that eat fish and all the people all over the planet. So I'm so scared that the space is going to be like that too, right? Like you're going to end up having people like blow up some comet. They're like, "Oh, we really care about the minerals in this comet, and we're going to redirect it somehow so that we can get access to it." And then suddenly it's like, oh wait, actually, oops, like now it's gonna come right at us. And
Yep.
this like plume, they're like, yeah, it's a plume of minerals that we care about, but actually now it's gonna land not in
But
the middle
now
of
it's
yeah. and
like
and
now we're gonna be killed by the minerals.
yeah, and then there's like a tragedy of the commons thing where like it's a shared resource, but then there's no governing anything, and then
Mhm.
like I mean, look what's happening to the ocean. Like we can see
Yeah.
like sample. Like we are
Yeah, and
not
it's
good at this.
interesting.
Humans
Yeah.
are not good at this.
And especially, I think like one of the more plausible like ways that could happen is so like we ruled out the possibility that we're going to get hit by like a planet destroying asteroid. But like what we haven't ruled out is the chance of an impact by like a city destroying asteroid. Um, it seems like there's a lot of those probably out there that we don't really know about yet because they're much smaller, they're harder to track. But I think that's the case where it's like, okay, we detect one of these and you deflect it away from like you're like, oh, this is going to hit New York, so you deflect it away from New York, but then does it hit like Panama or something? And like also because the effect of it is more localized, that's when you get like where FFG said like these ethical dilemmas, and it's like, okay, which countries actually have the means to deflect them away?
Yeah, I have so little
Yeah.
trust now in humans. I happened to watch a nature documentary about the ocean like this past week. It was dark.
And actually, yeah.
And I was like, oh, okay, this is what happens if, we are unchecked, right? And then capitalism takes the takes the wheel. And
I will say, I do think we have been historically better at that in space. Um,
oh, because it's like a select few of countries have access to it, and so they
and I
negotiated
mean,
a little bit better.
Yeah, and I think it's because it's like there aren't really that many established space industries right now. Like people are able to kind of learn from the problems that have come up too. Like it's like it's hard when you have fishing and you have like whole regions whose economy is dependent on doing this thing that's also destroying the ocean.
Yeah.
Versus I feel like space, like we were able to anticipate. Like for example, like a few countries tested anti-satellite weapons, and then we pretty much figured out that you should not do that because the problem with blowing up satellites is that it actually tends to start a chain reaction that can blow up like all the satellites. Basically, you blow up one satellite and it produces a bunch of very high velocity satellite pieces, which then just stay in orbit and hit other stuff, which then breaks apart into pieces. And so basically, you end up with low Earth orbit just being covered in gravel, and then you can't put anything in there.
Yeah.
Um,
I was gonna say the tragedy of the commons hit our space trash already, right? Like every antenna we put up, every satellite we put up, like that we no longer have a plan to bring them back down. They're just floating in trash. Like it's a floating trash lower
but
orbit
I feel
right now,
like
right?
But I feel like we've done a good job at mitigating that too.
Have we?
Like I think so. Yeah. I
Oh,
mean,
maybe we should do an episode on space trash so I can read more about it. I remember it being like this is like a huge problem, especially with like the old trash because like we didn't keep track of the parts and now they're all disintegrated and they're like little pellets and they can just like puncture do all kinds of things because they move at really fast speeds and it's so
yeah,
littered and every country can like it's hard to have a full manned flight like space flight thing but it's reasonably priced for most countries to come up with a satellite to send up.
yeah. I mean, like I think it definitely is a problem, but it's much less of a problem than it could be. I think
Yeah.
is what most people see. So like right now, like what it usually looks like is, for example, that like you'll have a satellite up in space and you'll get a notification that basically says like, hey, you need to move your satellite. It's about to get hit by something. And then so you have to like make this emergency maneuver, which is like, I mean, it's not ideal. It uses a lot of fuel that the satellite has a limited supply of, but it's like we actually are really good at tracking the things. It's I mean, it's like we can do it. It's still feasible to put up satellites, which actually wouldn't necessarily be the case if this problem could easily have gotten out of control to the point where it was like no longer possible to launch anything into space.
That's true.
Um,
I was thinking about actually the satellite. Could we save some satellites in the event of a giant solar storm and like a massive CME thing? Could we like make it fly to the other side of Earth and use Earth as a shield?
Yeah, I think
Could we
so.
park
I
them?
mean,
They're like,
yeah.
it's coming in 12 hours. Like, park everyone, move your satellite to the other side of the planet and, shield, go into you know, like turn everything off
Yeah.
for like 5 hours and like wait
I
it
mean,
out.
I think the problem is that the satellites usually can only be behind the Earth for like depending on how high they're orbiting for like 90 minutes to like a day. Um, and
Okay.
like basically because of how the orbit works, if they I mean there's some that actually have really weird orbits where they kind of like they're very kind of pokey on one side, so it's like it's going around and go
Yeah.
like that.
Yeah.
But for most of them, like in order to not fall back to Earth, they would have to go back onto the sunlight side eventually.
Yeah. After the solar storm.
Yeah, I guess I mean I feel like yeah, potentially. How long does a solar storm impact satellites for?
It depends. The Kerrigan event was like 2 hours,
Hmm.
right?
Yeah,
Like,
yeah,
yeah, so like those well, 2 hours as in for 2 hours, these people that were hitting Morse code could work on their
yeah.
telegraph for 2 hours without actual power. So I'm assuming it's still there, but like not bad enough where it would fry it.
Right, like there's a peak and then yeah.
Yeah,
So I guess some satellites could probably be safer.
they could like
If
hide
they
for a little bit.
Yeah, I mean usually the satellites don't carry enough fuel to change their orbit that dramatically, so it would mostly just be kind of like a matter of luck, like
Yeah,
okay, are
luck
these
of the draw.
ones
If you're,
yeah.
oh, it's
The
so
other reason these
wild. Yeah,
things suck for people who own satellites is that the other thing it does is it actually heats up the upper atmosphere, and that causes the upper atmosphere to basically swell up and get larger. And that means that some of the lower orbiting satellites are actually no longer in space. Like they're now in the atmosphere and they start to encounter drag and like fall back to Earth.
oh,
Um,
and will it just like burn up in that entry and then
yeah.
become?
Yeah, it's a pretty mild effect, so it's not like they're all going to burn up like right then, but basically it will, for low orbiting satellites, a big solar storm kind of destabilize their orbits instead of circling around at their altitude. They just kind of keep clipping the atmosphere and going lower until they crash into the Earth. Um,
I do think that probably should be like one of the new rules. Like anything you send up should have like a end plan. That's
yeah,
not
that
just float it
actually
forever.
that actually is one of the new rules.
Yeah. Okay, so that is a new rule.
Yeah, yeah,
Cool.
yeah. Mhm. Yeah,
Um
Yeah, pretty much any satellite that we send up is supposed to either be in a low enough orbit that will eventually just crash back into the Earth passively,
yep.
or have the ability to crash itself using control. Or interestingly, for some, actually, one of the things they'll do is in some cases, it takes less fuel to just raise the orbit up higher than it does to crash it into Earth. So there's actually this part of very high Earth orbit that's called a graveyard orbit, and that contains basically just dead satellites, and they're high enough up to not interfere with the working satellites.
Oh. So they're like, okay, go it's already like a garbage patch. Like let's
Yeah,
just
yeah, yeah.
go.
This has been kind of one of the standard procedures for a while. Um, Look at that chair. Oh yeah, this is. I think I was in one place. I was talking with someone, and they're like, "Why do you have this like Star Wars chair?" Uh,
You're one of the sound pods, right?
yeah.
Yeah.
So for some reason, this building that I'm in, they bought all these like $30,000 chairs for some reason. Uh, anyway, yeah, it's fun. But yeah, I'm in the conferencing room.
Yeah.
But what was I saying? Anyway, yeah. So this has been a standard procedure for a long time, or not for a long time, but for a while, is to basically there's a very high orbit that's reserved for dead satellites, and you put them there when they're starting to break down and to try and get them out of the way.
Got it. Okay,
Yeah,
cool. So we have a space garbage patch as well. We're
yeah,
gonna
yeah. Like that's what I'm saying. I feel like we're doing okay at dealing with space garbage. Like I feel like we're doing better with space garbage than normal garbage.
That's fair. Oh, we're doing so terribly with normal garbage. I'm telling
Where
you,
there's like
if you watch a David
there,
Attenborough nature documentary about the ocean, he's
yeah,
he just leaves so depressed. Like he'll show you like a video of like this is what this reef look like, and this is what it looks like 12 hours after trawling. And then you're like, why
yeah.
is this legal?
Like why are you allowed to do this? Yeah, like at least in space there aren't like random like McDonald's toys floating around up there. Uh,
Just weather things and
yeah.
satellites for
Speaking of speaking of satellites though, so I was going to a really a really interesting thing that has also happened recently, and this relates to both the asteroids and also the satellites, is that we found a comet from another solar system, which is approaching our solar system. So this is the third one that we've ever found. The first one was just a few years ago. It was called Aomamua. I don't. It's very hard to pronounce. It's in Hawaiian, but it was super weird. They were like, "Where? What is this?" And then we started looking more for these things, and it turns out they're not that rare. But
Wow, this one was just discovered on the 1st of July, like literally this month.
yeah. It's very recent, and actually, I think one of the things about these interstellar objects is that they move extremely fast. So, um, they tend to always be discovered pretty recently because it's like you really just have like a blink of an eye to see it, or you just miss it completely. But yeah, this is um, yeah, Avi Loeb he is a Harvard astrophysicist who has been really interested in all of these. He thinks that they're actually all alien spacecraft, which um, I think is an interesting take on that. I think, but yeah, this one is called um, 3I/Atlas, which is named after the telescope that discovered it. And it's actually, I think this is the first one that we've found that is kind of when it was first approaching the solar system, which is interesting. Oh
Yeah.
yeah, so actually, yeah, so Loeb actually has said that this one could be an alien spacecraft. So the the very first interstellar comet that we found, which is, well, actually we don't know it was a comet. The very first interstellar object we found was called Oumuamua, and it had this weird thing that happened where essentially, so if it is just kind of passing through the solar system, any object should behave in a very specific way because of the sun's gravity. So it should be very predictable how it travels. And what seemed to happen with that first one that we saw was that as it passed by by the sun, its acceleration actually changed. And so you can't really account for that by gravity. It means that it has to be basically emitting some kind of mass like a rocket to speed up or slow down. Um, Now, one thing that actually does that is comets, because as comets get near the sun, they have ice that starts boiling off, and that acts as a jet. So most people are like, okay, so this is probably some type of comet. The weird thing is it didn't seem to kind of have a tail like a comet does. So there's been a lot of speculation about like, okay, what exactly was going on with this thing. The best explanation is probably that it was like a rocky thing with some gas trapped in it, but the gas didn't really form a visible tail as it boiled off. But I think, but Avi Loeb basically claimed that this was evidence that it was an alien spacecraft and it was maneuvering, which, I mean, we don't know it's not, but
So if all the water boils off of it,
Mhm.
like previously when it hit a like when it took a drive by another solar system and then suddenly it's
Mhm.
in ours, then it could just be a dry hunk of, like, even if it was I mean, it's just a dry hunk of stuff, right? At this point, right?
Yeah,
Like there
yeah,
probably wasn't a life form in it by the
right,
time it
yeah.
came through our solar system.
Yeah, and the question for I mean, the question that all the physicists are trying to figure out. So that very first one had two things about it that were really weird. The first thing about it was that its brightness seemed to fluctuate a lot in a rhythm. And like with something that's that far away, what that really tends to mean is that it's like a very thin stick that's tumbling. That's
Yeah.
usually what
I was gonna
causes
say
that.
like a plate.
Yeah,
Like something that
exactly. Yeah,
tumbles, yeah.
yeah. And comets are usually not shaped like that. So that is one of the mysteries is like why is this thing shaped like that?
Mhm.
The other one that they were trying to figure out is since it doesn't have this trail of dust like comets usually do, why is its acceleration changing? Like it seems like maybe something is boiling off of it, but it's not exactly like how a normal comet would work. Like I think like that is one of the theories that was raised is kind of like what you said is like, okay, maybe this is a very old comet that's like been traveling for a really long time. So it's kind of all the dust has already been um, like kind of dispersed off of it, but it still has some things that could boil off of it. Um, it's it's really, I think one thing about these objects that is kind of frustrating is basically when we try to image them, they show up as essentially one single pixel. So it's very
Yeah.
hard for us to see what's really going on with it,
Yeah.
which is interesting about this new one. So, because this new one we found it kind of early, there's actually been proposals that we could redirect some of the space probes we have out in space to go intercept it.
Oh, and like point a
And
camera
then,
at it and see
exactly,
what's up.
yeah, like we could image it up close and be like, what is this? I don't think it's going to happen because like, it would be very technically difficult and um, it would mean giving up on like the mission those space probes have been sent to do for the last like 12 years. But we could theoretically do it. There's actually the ESA is actually like the European Space Agency is also planning to make basically a space probe that will loiter in space until we detect one of these things again, and then will basically be specifically designed to chase it down and intercept it.
That's cool. Mindshell
Yeah,
says, I think Avi is taking the rhetorical angle as well because the idea of non-human tech is still very taboo. Oh yeah, this is about the
that's fair.
the the
Yeah.
the plate
The
flat shaped
Yeah, or I think or
comet.
I think just I think his general take, like Avi's general take on these objects. Honestly, I felt like he kind of lost a lot of credibility. Like the first one, he was like, this object is maneuvering strangely. Like this first one that he found, it's like, okay, it's weirdly shaped. It seems to be accelerating weirdly. Maybe this is some extraterrestrial technology. I'm like, okay, that's plausible. Like, then another one shows up and he's just like, maybe this one is also extraterrestrial technology. I'm just like, okay, I mean, maybe. I feel like you lose credibility if you say that about all of the things that you
Yeah,
find.
and like he's just like the guy that calls wolf, and then when we actually do see
Yeah, exactly. Also, like his argument for why this one is an extraterrestrial spacecraft is that it's traveling basically in an alignment with the orbital planes of the planet. So it'll pass close by a lot of planets. So he's like, okay, that's the behavior that you would have if you were sending a probe to study these planets. But then he's also is like, but also when it passes through the solar system, the Earth will be on the other side of the sun, so it will be hidden. So I'm like, okay, so you're saying it's an alien thing because it's going to pass by a lot of planets, but it's also an alien thing because it's going to not pass by planets. Like,
what is this
I'm just
logic?
like, I don't know if I buy this argument. It seems a little unfalsifiable, but I just lost your audio actually. It must be the solar flares. Oh, still not working. Yeah, let me.
What about now?
Oh, now it's working. Yeah,
Okay, that was weird. I also lost my train
solar
of thought.
flares.
Yeah, solar
Oh,
flares.
sorry.
We can blame it all on solar flares. Um, no,
Or aliens.
I can't believe I lost my train of thought. My bad. It's Friday afternoon, I guess.
It was the aliens they didn't like us talking about.
Yeah, they didn't want us to talk about it. They like stole it from the tip of my
Yeah,
tongue.
out of your brain. Let's see. Were there other things you wanted? I'm gonna check our outline and see if there was anything else.
Oh, I remember now. I was gonna talk
Oh
about
yeah.
the
Uh-huh.
technology used to capture the comets actually. So this is
Oh.
actually kind
Uh-huh.
of cool because this is developed in and this is actually something I kind of sort of work on because I just sat next to someone on the
Capturing
plane one
comments.
time. No, the imaging system. So
Oh, okay.
yeah,
Yeah.
those of you who don't know, I use imaging systems to study animals or the brain. So I do a lot of calcium imaging and other kinds of imaging. And I
Hmm.
spent last summer like learning how to build microscopes and stuff. But anyway, I kind of like have my finger on the pulse of cool imaging techniques. And the ones that they use to capture these comments is something called event-based cameras. So instead of like traditional cameras, which is what we use now, for imaging, like let's say like a video camera or even like on your phone, they have like just like you basically take lots of photos back to back and then like string them together. And then so the problem with that is that you have to pick a frame rate, and like like you're just taking photos, like if you want to capture a comment that could come at any random time and suddenly will just be there for a blink of an eye. You can imagine like if you just happen to be not capturing frames at that time, you'll miss the comment. And
Hmm.
so what they've implanted, what they've installed on the ISS and a lot of these satellites are event-based cameras, which on one hand has like this the advantage of not collecting a bunch of frames of black space. And
Uh-huh.
it will
More
only
frames
yeah,
without comments.
yeah.
Yeah.
So it would only capture things when there's change in fluorescence. So it's
Hmm.
basically
Hmm.
like an event detector, basically. So like normally it would collect no data, but it's constantly looking. And then when there is a change in the photons that are like it hits this particular cell, then it captures the moment that that happened. And if you imagine, you can do that in like like the chip, like a chipset like that, and you can use that kind of information and get temporal data by like literally every pixel when it had an event change. And that's actually how those cameras work. So it's a completely different way of doing like imaging, basically. Like you don't to go by complete frame, like you don't go by like you don't take the whole frame, because otherwise you would end up with
Right.
like however many pixels by how many pixels of black and just like years worth of that data. It would be huge and massive, and it would take forever to send like through the satellite to back to
Right. So
earth. It's just
you only take frames when you think there's something interesting in
that
them.
changed. Yeah, and so literally
Yeah.
every frame it takes, it's just like when something like flew into frame, like a comet. It's like it came, boom, and it's gone. And then you would have that
That makes
photo
sense.
because
Yeah.
it's always constantly looking, kind of. It's a very
Yeah.
different way of doing imaging. And I'm really excited that it's like now in like the regular world. So I'm using it now.
Hmm.
Like I'm writing a paper on how to like use it to image like rodents and stuff in the dark, so we could
So
like
people
monitor
are going to
them.
even use this in neuroscience too to look at like just only taking frames when like cells light up, or.
Yeah, or when shit happens, so that we don't end up with
Hmm.
like 40 hours of useless data um, of like a mouse sleeping or whatever. Like you just want it when it does the thing. And we just get the time locks. I don't know. Anyway, it's one of
That makes
the
sense. Yeah.
yeah, but this technology was designed literally by like, NASA, or not NASA, but like by the government to, look at
By
space.
people studying space phenomena. Yeah.
Yeah, yeah. And that's exactly how they found these.
Like,
And it's not like
yeah.
extremely more expensive. It's just like how it's like hooked up. Like it's just like a
Yeah.
design. It's a complete like design change. Like it's like not trying to see like we see, which is what our video cameras are doing, right? It's like just picture, picture,
Hmm.
picture, picture, picture. And you can like change the exposure and you can do all kinds of stuff like that. Like there's not like you set the gain, and then you just like wait for events to happen.
Yeah.
Anyway,
I
I'll
do. I mean, I do like it feels a little bit weird to me to use that because like I feel like you're potentially missing out on seeing things that you don't know to expect, if that makes sense. Like, I guess especially in a neuroscience context, like I feel like there's been a lot of things where people are, oh yeah, these cells aren't doing anything, and then they look back at the data later and they're like, wait, they were doing stuff.
yeah, and then here you would just be like, "Ah, it was there or
And then you'd
wasn't."
never get that. Like I mean, maybe it's good for like if you have a very targeted analysis and you're like, okay, we only care about this very specifically defined hypothesis, but I don't know. I feel like we found so many interesting things through kind of incidental findings like that that it makes me a little sad.
Yeah, I mean, like there's pros and cons of every technique, right? Like
Mhm.
this one has
Yeah.
some cool advantages, and it has some drawbacks. And a lot of people that are used to seeing data across time, like this would be really weird, right? Because you're like, yeah, I can slice it anytime you want. Like, what do you mean you can slice it anytime? Like, I can create you a video at any time scale you would like. Because I only collected these random
Like
timestamps
when things happen.
and
Yeah.
positions, yeah.
Yeah.
And then like luminescence at that. So like one of the other pros is that it works really well for things that are super, like it's very sensitive, right? Like as long as the detector can pick it up, it'll log time events. So like a super far 1 pixel event, like 1 pixel comment in the corner of the screen, like as long as it's pointing at the corner of the chip, like that one little thing, it's really good with signal and noise. Basically, like it's
Hmm.
fairly confident that that 1 pixel that appeared and then disappeared was real.
Is a
Because
thing. Yeah.
yeah, because you don't have this SNR situation where you always constantly have it on and you're like dealing with like that kind of noise. You literally start with nothing, right? It's a very different way of doing imaging.
Yeah, that's interesting. I should read that paper because I feel like I don't fully understand like why that has better SNR.
Yeah,
Yeah.
we should talk offline.
Yeah.
I just brought it up because I was like, oh yeah,
Yeah, yeah.
that was the technology they used to like find the comments, or like
Mhm.
see
Neat.
the like
Yeah.
to capture it on screen or on a device at all.
Yeah.
Cool.
It's interesting like, when you look at when they found this interstellar one, it's like it's pretty interesting because basically you see like this against this background of like a whole bunch of different stars. It's this wide field imager, so just looking up the night sky and it's like there's tons of stars. You basically just see this like 1 pixel moving and they have algorithms that are like, okay, that's a thing.
Oh wait, this one. Oh, I'm just looking at
Yeah.
the comment that you talked about today. The one
Three
that was
iris
discovered
slash
like this
atlas.
month. Yeah, it used the Hubble Space Telescope.
Oh, it did?
Yeah.
Oh, I thought
The
it was
Oh well, there's a photo of it using the Hubble. I don't know if the Hubble
yeah.
discovered it, but the Hubble
Yeah.
is pointing at it now.
Yeah, that makes sense. Yeah. I think it was actually discovered using this thing called the Asteroid Terrestrial Impact Blast Alert System, which sounds very ominous, but it's one of these systems that like we were talking about earlier it's one of the systems that's involved in kind of scanning for things that could potentially impact the Earth. And it turns out it's really good at picking up these sorts of things too, because it is constantly looking at a very wide field of view, and they
Yeah.
can just have some really sophisticated algorithms that can pick out anomalies in it.
Yep. Yep. They probably found it and then they just pointed the Hubble at it.
Yeah. Mhm.
Wow, it's really
Oh
fast.
wow! So they have an actual picture of it now from the
Yeah,
Hubble.
there's a picture of
Yeah.
it, and they even plotted the trajectory of it since March to to June
Yeah.
25. Yeah, this is cool. 2024 to 2026. 10-day intervals marked with red points. Yeah, I'm just like on the website
Yeah.
on Wikipedia actually. This is kind of
Wow.
cool.
Yeah. This is
I
like that is really cool. I didn't. I guess that's just because we found this one earlier. They were able to point the Hubble at it because I feel like with the first one they found, like they weren't able to get any real images of it.
Yeah. Yeah, this is cool. They have like moving like images of it too. Like there's literally a movie
Mhm.
of this thing flying across. This is so cool. Very good. Anyway, highly encourage you guys to look up in the sky in the next
Yeah, go
week or
see
so.
the Perseids next couple weeks.
Yeah. And I guess like enjoy the auroras and like don't freak out.
Mhm. I will, if we want to end on like a positive note, I'll say like the trend has actually been for kind of like the sunspot activity and the solar storm activity has been decreasing over the last 20 or 30 years. So it seems unlikely we're going to get a big spike in it anytime soon.
Yep. And then, once we're through this period of, peakiness, it's gonna go into minimus and we're gonna be
Yeah.
good for the next 10 to 11 years.
Yeah, and
Before,
also the US will like invade less countries.
yeah. Yeah, it's just, sometimes it's like you're waiting for the other shoe to drop because you're like, you're sitting there and you're like, oh, it's around time. 2025, 2026. We're at the window, we're in the window. But yeah, like maybe we'll make it be like, let's make it next year or 2 years, and then things will get better. Because then it'll be headed towards the minimus of
Hmm.
this of the solar year, and then we're heading, in the right direction for 10 years.
True. Yeah. Hmm.
Cool.
Yeah.
With that, thank
Well,
you for joining us. We're
yeah. Thanks.
philosophizing. Join us again next week.